Bom dia a todos. Estamos fazendo a abertura do terceiro dia do workshop Engenharia de Requisitos, edição 2020. Eu gostaria de agradecer imensamente ao professor Tony Gorschek por ter aceitado o convite para participar como Keynote Speaker nessa edição do WER. Eu vou fazer uma rápida introdução sobre o professor Tony. Tony é professor de Engenharia de Software no Instituto de Tecnologia de Blekinge, na Suécia, onde trabalha como pesquisador e cientista em colaboração com parceiros da indústria. Ele tem mais de 15 anos de experiência na indústria, como Chief Technology Officer e consultor executivo. Tony também é um empreendedor com 5 startups criadas na área de serviços baseados em internet e logística. Atualmente, ele é o pesquisador líder em vários projetos, desenvolvendo soluções para as áreas de engenharia de requisitos, gerenciamento de produtos, desenvolvimento de produtos baseados em valor e metodologias ágeis. O professor Tony lidera o projeto CERT, Software Engineering Thought, que é a maior iniciativa em pesquisa na área de engenharia de software da Suécia. Eu gostaria de mencionar que tenho colaborações em pesquisa com o Tony na área de engenharia de requisitos para sistemas críticos. A gente tem colaborado desde 2014. Então, é um grande prazer receber o Tony aqui no UER. Tony fez um pequeno ajuste no título da apresentação dele, que vai se chamar Engenharia de Requisitos, Desafios, Ideias e Futuro. Agora eu farei essa apresentação em inglês. So I'd like to thank Professor Tony Gorschek for accepting our invitation to participate as a keynote speaker in the workshop on Requirements Engineering, WER 2020. So I will introduce Professor Tony Gorschek. Tony is a professor of software engineering at Blekinge Institute of Technology, where he works as a research leader and scientist in close collaboration with industrial partners. Dr. Gorschek has over 15 years industrial experience as a CTO, Senior Executive Consultant Engineer. In addition, he is a serial entrepreneur with 5 startups in fields ranging from logistics to internet-based service and database register optimization. At present, he works as a research leader and in several research projects, developing scalable, efficient, and effective solutions in the areas of requirements engineering, product management, value-based product development, and real agile and lean product development and evolution. Dr. Gorschek leads the CERT Profile Software Engineer he taught, which is Sweden's largest software engineering research initiative, developing the next generation of applied empirical research movements to meet the challenge of the next generation of software-intensive products and service. I'd like to mention that I have collaborated with Tony in the topic of requirements engineering for safety critical systems since 2014. Thank you very much, Tony, for the research partnership along these years. The title of the talk is Requirements Engineering, Challenge, Ideas, and Future. So, Tony, you have the floor.
Thank you very, very much for that kind introduction, and thank you for inviting me to speak. I hope not to bore you too much. I would have preferred to meet all of you guys in person and have some nice coconuts and some beaches, but it is what it is. So we'll try to do it as we can. I was asked to speak a little about requirements engineering in the future, and this is very dangerous stuff, because if you guess wrong, people will have the slides and the recordings. So I was thinking about talking a little about what I think will be the next challenges in the area. But it's not pure requirements engineering, because requirements engineering is only one part. So that's kind of the outlook. And this is from personal experiences and from what we're looking at from the companies we work with. So it's not, empirically true. I'm not presenting a paper. I'm presenting more overall view of what I see happening in industry. That's kind of the idea. And our collaboration, as many collaborations with my Brazilian friends, is you do most of the work. I feel a little guilty for not doing enough. So I thank you guys. So let's move on. So Tony, my name is Tony. I've been an engineer for a while. And in general, I was actually working in industry for about 15, 18 years. And then I kind of got tired of it and sold my companies and wanted a new challenge. And somebody convinced me to become a researcher. And I realized very fast that it's still, research is still very much like working in industry, because you have deadlines, you have budgets, you have projects, you have collaborators. So the only main difference, in my view, in working with industry as a researcher is that you can be more honest. When you're working for a company, you kind of have to be loyal and honest to that company, but you still cannot be completely honest. And when you work as a consultant, you're selling hours. You can still be reasonably honest, but you still have to kind of sell hours. The really good thing about working as a researcher in my book is that you can be completely honest, because you're independent of the companies 100%. And that, I think, is a very good thing for a researcher to be able to be. So yes, you of course have to sell ideas to the companies for collaboration, but the second you start selling the ideas and not trying to solve problems, I think the companies don't like you as much. And also, I think that it's not worth being a researcher then. So that's kind of my outlook on how to work with industry. Trying to be constructive, humble, because most companies we work with are very successful, which means they don't need me, but I could potentially solve some problems that they don't have time to do. And that's kind of my outlook on working with industry. So if we look at BTH, we were like 2 people in software engineering when it started about 15, 20 years ago. And we've grown a lot, and we're expanding a lot. And what we're doing is primarily industry collaboration and industry-based projects, which means that companies pay our salaries and we do work for them. The 2 main problems we have is solving problems, which is a challenge, because we try to solve problems for companies that they can use, and also finding good people. Those are the main 2 problems. So I'm shamelessly plugging that we're hiring people. So if you know any good PhD students or seniors who would like to come and work with the team for a couple of years, let us know. So if going to the topic of requirements engineering and what requirements engineering is, what I've noticed a lot in research, but also especially in industry, is that generally when you say requirements engineering, people kind of think about specification of some sort. So think about backlog, maybe a post-it note or a more formal specification, but they generally think about writing stuff down. But I think that's a bad thing, because when I go to a company and I start talking about requirements engineering, they say, we don't do requirements engineering. And I'm like, well, how do you know what to do? Yeah, but that's not requirements engineering. So I think that there's a common misconception about requirements engineering. I don't know how specifically that much about if this applies to Brazil, but in general, what people want is literally figuring out how they can buy, build, or produce or use services to do the right thing or do the thing right, and choose what features to implement. So if you have an airplane, you want to figure out how large should it be, what features and quality aspects should be implemented in the airframe or in the software. So you want to figure out what to do. And this is not generally seen as requirements engineering in many companies. It's seen as product management, release planning. It's seen as design. It's seen as other things. But the word requirements engineering is not really used that much in the companies I work with. Rather, they more use other terms, but it's still the same thing. Another thing which requirements engineering, a very important part of requirements engineering, which we generally sometimes miss is that it's the non-functional aspects of requirements engineering, which is among the most challenging things to plan and to realize and test. So for example, the usability of a product, which is somewhat of an hype, still very seldom is specifically specified as a part of the specification and then actually followed up, but rather it is more fluffy, so you focus on the features. So procurement is something the companies we work a lot with. So how do you buy software? And when you procure, you do a lot of requirements engineering, but they don't call it that. Product management, when they're literally deciding what the product should contain, which product should be developed, and how the releases should look like, that's also part of requirements engineering. So is release management, total cost of ownership, total solution environment. If you have many products, for example, a hospital, well, they don't have one piece of software. They have 500 different pieces of software from different vendors interacting. And here, requirements engineering, all of this is called for requirements engineering. And I think that there's a risk that you kind of focus on your own thing, and we're even worse as researchers. We kind of focus on a very small part of a very small part, right? So we say requirements engineering, then we have our definition of requirements engineering is fairly narrow. Let's say safety critical systems, right? And then within that safety critical system requirements engineering, we narrow further into, for example, interactions between requirements. And then we look at, for example, how to use natural language processing to identify duplicates or interactions between requirements. That's a very, very thin slice of a big, big, big thing. And the problem with that is we kind of do our thing and do the research, but we don't really put all the small things together so that it is a solution for industry. And I think that's something we have to become much, much better at. I'm not saying we cannot solve discrete, smaller problems. I'm saying it needs to be packaged in an environment or in a framework that the companies understand why they should care. And I think that's kind of important. So when I go out and talk about requirements engineering, I generally avoid the word requirements engineering because it's very, either they have decided exactly what it is, or they have a very limited view of what it is. And that's kind of the dangerous thing to speak about. But from a research perspective, we know this. So in addition to this, requirements engineering is set in a context of engineering, right? And you have ways of working, but you also have technologies, and you have different parts of product development where requirements engineering is a central piece, but it still interacts with everything. So for example, one of the principles we've started working with in companies is replacing requirements with test cases. So instead of writing requirements in a backlog, we write test cases in a backlog as requirements. This is an example of achieving requirements engineering purpose, which is figuring out what to do and how to do it. And at the same time, writing test cases you can use later. So I'm kind of trying to say that I think it's good to be agnostic. The method you use, or the tool, or the way of working you use shouldn't be more important than what you want to achieve. So for example, I'm working with an automotive company. They don't really care about requirements written in a language that says the system should. They want to know exactly what the tolerances are. They want to know exactly how to work with developing the car concept. And there we can just as well use test cases to test if the requirements is implemented as a requirement. Now, the negative thing about this is that you jump to solution too fast. However, previously you didn't write any requirements at all. So there's always also a trade-off. And basically the trade-off is in relation to efficiency, effectiveness, and scalability. So yes, you can write 10 requirements very well, but it doesn't scale if you have 100,000 requirements, or 10,000, or 1,000 requirements. So how can we do good enough to figure out what the purpose is and actually do it good enough so that the company actually uses the method we're supplying or suggesting. And this is also something I think is important for researchers in the field of requirements engineering, is not only figure out how you can do it perfectly, but rather how can you do it so somebody else will actually use it. And I'll come to a little more about that later. So the important thing, what I kind of wanted to say is that requirements engineering is kind of a big field, and it's put into the context of engineering. And software engineering is also part of engineering overall. I don't think I have a single company I'm working with who does software. I only have companies who do software-intensive products and systems, which means that software is important, but engineering is overall important. So we putting it in the context of the product development organization or product planning organization is kind of important, because then we can figure out how the methods we're developing for requirements engineering can work for engineering overall, and not only for a very specific case, because then chances are it won't be used. So what's the problem? Well, there are many problems. We kind of we talk generally about 6 micro challenges, and that's the macro challenges are basically size and complexity is increasing, as we've been saying for a very long time, but it's increasing a lot in relation to later years. And this is especially in relation to emergent properties and interactions between systems. So if you look at it, only 15, 20 years ago, you had rather distinct infrastructure or ecosystems of software which you used, right? So for example, you use the Office, Microsoft Office, and you use that and you're happy with that. But today I use Office, but I also use Overleaf on the net at the same time, and I also use Mendeley, and I also use a couple of spell checkers and grammar checkers online, which are plugged in. And even in this super simple example, we see that we have 5 or 6 or 7 different vendors, different companies with competing interests being used by me as a user. Now think about this in a more critical fashion. For example, fourth generation collision avoidance and autopiloting in cars, which we're working a lot in. Well, there you have the LiDAR and the radar systems and the cameras from different vendors bought in by the automotive company integrating them. But then you need a service provider for the telecom system that is actually communicating with real-time data between cars and between base stations. And then you have apps you can download to kind of optimize your driving at the same time as you use autopilot. So all of a sudden, in this safety critical real-time, close to real-time system interaction, you literally have a situation where you have 5 or 6 companies delivering different types of software, and there's nothing to say that they're actually talking to each other before they develop anything. So, you know, this idea of having all the requirements specified, or even in an agile environment, you know, when you put stuff in a backlog and do iterations, yeah, but there's no real difference between a plan-driven process where you get all the requirements from the beginning and an iterative process, except how long it takes for a cycle. It's not like you deliberately skip requirements in an agile cycle. No, you don't. You package them as well as you can and do a release or do an iteration, then you take the next iteration. Same for a normal product development. But the idea is that you can kind of identify the requirements up front. You can for some, but you also have emergent properties which are very, very hard to guess beforehand. Maybe 2 years after your product is released, requirements come in that are completely surprising you. And this is kind of one of the biggest things that the companies are figuring out. And then you have negative effects of this. Some say, for example, there's no point in doing requirements engineering because we don't know what's going to happen anyway. Yeah, but then you can say, well, if you don't do any requirements engineering, what are you going to build? I will listen to the customer. Yeah, but there's nothing to say that the customer is right. Just because the customer wants something doesn't mean that's what you should develop. I'm not saying you shouldn't listen to the customer. What I'm saying is they might not be correct. And this is kind of a big challenge for industry because they want to use a lot of data as input, but they don't really know how. At the same time, they have challenges in relation to the macro challenges, complexity and system interaction, emergent properties, long lifespan, etc. And that's kind of the context in which we're working in the new requirements engineering world, to be honest. And we've been doing research on this since 1964. I think that's the first mention of requirements engineering in a conference. So we should basically have prepared a lot for this, but the fundamental problem, and I'm kind of making fun of myself and everybody else, but I kind of say that sadly research is not always focused on the engineering part. So I kind of illustrate it through saying that you have a researcher, that's me on the picture, and the researcher kind of works in academia, and there's kind of companies and industry and organizations outside of academia, and the researcher has an idea. Sometimes that idea can be fundamentally great, or it can be completely meaningless, you never know, because you have an idea and you kind of do research about it and you kind of write it down in some way, and then you try to publish it, and you have a bunch of other people that are kind of like you, if you're unlucky, and you get peer recognition, and what you do is you continue this cycle because that's your livelihood. That's basically what you do. The more you publish and the better you publish, and the more people that agree with you, the better your career is. But the fundamental problem with this is that, do we use actual data from reality when we actually formulate our ideas? That's one question that I think is very important to ask. Another is, well, once we have our solution or idea, do we actually try it out? And I'm not talking about toy examples, I'm talking about real examples. I mean, if you take all of the methodologies developed in requirements engineering and try them out on a real case with real data, but scaled to a real scenario, I would say that maybe 1% can work, if that. And then you can always say as a researcher, that's not my job. Well, it is, simply because I'm not a scientist, I'm an engineering scientist. There's a difference. So I did my master's in computer science, and in computer science, it's more base science, but I'm a software engineering scientist now, which means that the engineering part, and does my stuff work in engineering, is very, very important, which means that the validation part and then the transfer part are kind of important here. And I think that's one of the challenges we have as researchers, that we're kind of talking too much in an echo chamber sometimes. And I'm generalizing because I've seen this for myself, and I've seen it for people that are really good and really smart, but you have a tendency to fall into the trap of listening to the echo chamber. And the best way to avoid this is start working with companies all the time, because then all of this disappears. And my major problem, to be completely honest, is the opposite. I generally work a lot with companies, but I don't have the time to publish. So I publish much, much less today than I did 10 years ago, or even 3 years ago, simply because I'm so busy with trying to validate my stuff. And the second it's validated and it kind of works, they have another problem they want to address, and I have to kind of jump into the next thing. So I have like 20 papers in the queue I should write, but I'm on to the problem 21 because I think that's more fun than writing papers. So it's always a trade-off. So what I think the next 20 years, there's a million things you can mention here. And I had a really hard time. So I agreed to this keynote a year ago, or 7, 8 months ago, when Louise asked me, and I said, yeah, sure, no problem. And then, of course, as always, 3 weeks before the keynote, what did I say I should talk about? So I kind of look up what I should talk about. Oh, the future. Oh, God. And I've been sitting for a while trying to figure out what I should say, because there are so many things I think are important. But I tried to settle for a couple. Then please forgive me if these are not the most important. But I kind of call them the big three. It's product management, it's agile, and value. And they are general concepts, but they are also very relevant from a requirements engineering perspective. And I've kind of highlighted product management a little because many people working with requirements engineering, at least in the companies I work with, are never called requirements engineers. They're called product managers or product owners, or many different names for them. But the ones who are deciding what should be implemented in a product and which product should be developed is not the agile teams. When the agile teams take over, and the teams take over, they generally have a backlog they're following, and they can of course add and modify and discuss it. But in general, they're not saying fundamentally which backlogs to ignore or create. And that's generally product managers, and product managers generally have the money for the development. So we'll talk about agile simply because, and when I say agile, I mean all the new flexible continuous methodologies. That's why I put it within this. And I'm going to talk about value for a while too, because that's kind of a Rosetta Stone concept. So it's kind of up front and center for whatever you do. Is everybody hearing me well and stuff like that? Does it work?
Yes, yes.
Okay, good.
Very good. Okay, hear you very well.
I'm just checking, so you know.
Yeah, just great. Thanks.
Okay, great, good. So this is what I hate about not having an audience. You don't see them, right? So the big three. So product management to start with. Generally, a product manager, you have a team of them, of course. It's very seldom one person. But in general, the fundamental challenge for product manager is overload. And recent 10 years, I've been working a lot with big data analytics. I've been working a lot with people who work with machine learning and AI. The fundamental problem is heterogeneous, huge amounts of data that is potentially very valuable for business intelligence, but it's impossible to go over it continuously and extract relevant information. I'm not saying it's not possible. I'm not saying that's not important. I'm saying thus far, whatever your tool you're using, investment analyzer for IBM, or you're using one of the market analysis tools or feature analysis tools, in general, there is nobody who can show that what they are presenting to the people as important is important. It might be important, but they might have missed more important stuff. And the key here is you have so many different types and different potential sources of good ideas, requirements we can call them, but it can be anything. It can be wishes, ideas, that you have to, as a product manager, kind of keep an eye on everything to try to catch the golden ones to put them in the pipe for development. Now, the fundamental problem with this is that not only is this hard if you only did this, but product managers also generally focus on firefighting. So they're often general top project managers for projects or sprints or teams, which means that a lot of their time goes into figuring out interpretations of requirements, right? So it's one thing that you collect the requirements you're going to implement in your product. It's another that you need to communicate that to the teams in the way that they understand it in the same way you do. And this coordination and communication takes a lot of time, which means you don't have as much time to actually do the feature selection, if you will. And finding the good ones based on business intelligence is one of the hardest things. So what we've been working on in product management, which is by no means done, is basically looking at how you can use large heterogeneous information sources. So think about it like this. You have a support database where the information is in one format, right? So like support cases. Then you have ideas from engineers internally, where it's more emails, coffee break discussions, that kind of thing. You have a third, which is legal and regulations, which is very formalized often, hopefully. You have a fourth source that is, for example, competitor analysis and gap analysis from competitors with products that look like yours. You have a fifth, which is customer requests. You have a sixth, which is customer usage data, right? And so on and so forth. So you have a huge amount of sources with huge amounts of data in each source, and they are different formats, different abstraction level, different notation, different accuracy, different and different detail. And that's the fundamental problem with automation. And you say, oh, well, AI will solve this. Yes, but when we have AI, we have completely other problems, like they taking over the world and we being irrelevant. So we don't have AI. We've never had AI. What we have is, at best, augmented intelligence and narrow AI. And the fundamental problem with narrow AI, you can write an algorithm for a very homogeneous static piece of data. But the second the data is heterogeneous and varies a lot in quality, this falls apart. But even if you could do that, then you can kind of traverse all of these huge databases and huge repositories of gold information and basically separate the bad from the good, or the interesting from the non-interesting. You need to do this by cleaning and analyzing it in some way, which is point 2. And then you need to put it together. I mean, you might get 6,000 entries that mean the same thing. So how do you do synthesis? How do you summarize this to be human readable? Because however you look at it, in step 4, in this very simplified diagram, in step 4, there needs to be a human taking a decision. Yes, no, do this, don't do this. It can be a team or a person or a product manager, it doesn't really matter. But basically, you want to be able to use all of this huge potential data, clean and analyze it, do synthesis so that it's human readable and within reason. Perfect example of this is from the testing world. So you run a big company I work with runs 650 to 700,000 test cases every night. In the morning, the chief testers, 4 people, come in and they basically look at their tools and look over the test results from the tests last night. And they basically see green and yellow and red. So I have 2 questions there. 1, how do they know that the greens are okay? 2, how did they know that the reds are actual problems? And this is the same principle here. How do we know, how can we actually do the automated steps, largely automated step 1, 2, and 3, and actually trust the results in 4? And that's another huge challenge. Then, of course, we do some sort of development, hopefully with fast experimentation and prototyping, to kind of experiment and validate on the decisions we make in step 4 to actually do the development. And then we feed it back and we start over the cycle. And this is a continuous cycle. The fundamental problem is nobody's really figured out 1, 2, and 3, except for very specialized cases. But the company doesn't have a specialized case. The company has a very, very wide case. And this is something very, very hard to kind of figure out. And that's one thing we're working a lot with. And I think there's a huge need for both specialized slicing in terms of research in these areas, but also putting that specialized research into the broader context of giving command and control functions in step 4 to humans to take decisions. And I think you need to do both. Hope it makes some sense. And if we move on to Agile, which is generally ways of working, you basically have the fundamental problem with Agile is, like with everything else, there's fashion, right? So Agile has been fashioned for a while, and they have different flavors, you know, from XP and Scrum. Now it's DevOps and scalable Agile, etc., and safe, etc. But the interesting thing is, from a requirements engineering perspective and from an engineering perspective, you generally have the same challenges as you've always had. And that's kind of a couple of things that you solved, or not solved, but improved. And you have a bunch of things that have never been solved, and there's nobody knowing how to solve them properly. And that's because it is immensely difficult problems. So a couple of things that actually works. Well, a couple of good things about Agile is requirements are owned collectively. So in an Agile environment, you kind of combine the problem and solution space into actual teams. So instead of having people writing requirements and then giving them to a development team, and the development team interprets this information, at best they do it correctly and not misunderstand it, and they implement it and kind of own the solution and own the problem, you kind of have teams working together. And this is kind of good because you can get less specification, but more things specified. You can work in team. It's less division between roles, which means you kind of take collective responsibility, you increase productivity and creativity. I think you have better solutions and improved communication and motivation. I really have seen this work a lot. But it's not necessarily due to the agile philosophy in terms of having a backlog. Rather, it's the philosophy of we're a team and the backlog is a tool, but you could just as well use a Word document. Wouldn't really, have a big difference if you work as a team. But the interesting thing is when you actually combine the problem and solution space in a team, what you're doing is you're pushing the information up and down. So you're giving the developers the why a requirement is specified and the problem. But you're also giving the people who are problem owners the how you're going to implement it. And then you can catch problems much earlier. So this is a good thing about Agile from a requirements perspective. Another really good thing is faster feedback cycles, right? So the faster you iterate, the faster you get input. Did I do the right thing? Did I have a misunderstanding? You also get better ideas, right? Yeah, this was interesting, but you could do this instead, which means you don't invest huge amounts of time and energy into a specific feature. Rather, you hopefully release lightweight features that can be improved and changed, rather than monolithic features you release very seldom, which then requires huge effort and cost to change. And I think that's kind of important. And the learning cycles allow you to predict and learn continuously within the teams. Fail fast and learn is kind of the point. The major challenge to this is, of course, it doesn't work in all domains. Fast is relative. I mean, when I work with ABB, for example, their iterations in agile teams is 6 months. And that's very fast for them. Normally it's 2 or 3 years, while for Spotify it's weekly. So you have to understand that one size does not fit all, and it's rather the idea that's important and not exactly how you do it. I actually call good agile chemistry and not a recipe, right? So if you look at it, you should be a chemist to figure out how things interact and work, rather than following a recipe, X, Y, Z, etc. So those are the good things. But there are also a couple of things that need solving, and nobody's solving them. We're trying, of course, doing research in these areas. That's why I'm talking about them, but it's not solved in any way. And that is the agility versus control versus scalability of product development. And this is directly related to requirements, simply because if you have a complex organization, which part implements which requirement, and how do you know you don't have overlap? So I'll give you a super simple, stupid example is, if you have an organization that looks at team A, B, and C, and you have component 1, 2, and 3, it works fine, right? Even A, B, C down below and component 1, 2, 3, that works fine. But the second team D enters and works with component 3, you get coordination necessity with team C. And of course, this is a super simple example, but it kind of illustrates also which backlog do you put what in and who owns what, and maybe team D and team C needs to divide a backlog item. How do you do this concretely? And how do you do this on a large scale? Even worse, what happens when you actually come to a real architecture? We have thousands of components interacting in hundreds of ways, and you have teams dividing requirements. And as you know, one requirement is generally impacting many components. So do you do backward front so that you have component division of requirements? Well, then it's not requirements anymore, rather it's design. Okay, we use requirements for the teams. Well, then one team, one backlog item actually impacts 50 components. How do you control this? And that's kind of, you want to move fast, but you need control in a real environment, and control doesn't scale. Neither does agility. And this is a fundamental problem. Nobody's solved this. They can talk about safe as much as they want. Literally, safe is more control than previous agile versions, simply because they're trying to tackle this. How do you handle complexity and control in an environment that should be free? the fundamental problem, if you introduce control in an agile environment, you lose the benefits of the agile environment. You can call yourself, I'm working agile, but if everything is controlled, you're per definition not agile. So it doesn't matter what you call yourself. And it's not somebody evil saying this, it's very simple. If the more agility you have, the less control you have. The less control you have, the more overhead you will get in a complex environment. And how you balance this, because there's no solution, I think, to this. It's rather a continuous problem, a continuous way of working. You have to figure out how to coordinate things. One way could be to simplify the architectures and make sure that the organization and architectures are refactored at the same time to reflect each other. And I'm talking about architectural components refactored in the same way you organize your teams. And that this is done continuously in the retrospective phases of agile team works, which means that you're continuously changing and improving the organization and architecture at the same time. And generally you do this very separately today, and I think that's a big mistake. But that's kind of some of the work we're doing, trying to figure out how to handle this. And of course, you have a big risk of duplication and also the loss of agility. I think that's the major things that are a problem. Another thing is you want to, in any environment, add value and remove waste. And I'm coming to why this is the core of requirements engineering soon, in my view. And that is how agile, but you have to go back and figure out how is agile implemented. It's not like, generally when agile is implemented, according to my experience, but not only agile, but which tool you use, how you do requirements engineering, which APIs you use. Many of these things are not really decided based on the best evidence. Rather, they're decided by a few people who just decide. There's a very interesting keynote by a friend of mine who actually said that the most common way Agile is implemented in organizations is a middle manager goes away on a short course and reads a book and then decides we're going to do Agile. Okay, what does that mean? No, it doesn't matter. Agile is good, do it. And then you kind of make a huge change in an organization. What we miss is Agile has no purpose in itself. None of it has. What's the purpose? Well, the purpose is adding value to a product or service and removing waste from the said product and service and how you work. So what you do is you want to add value and remove waste. And this is from Lean. So it's not invented by anybody recently, but you don't want to do anything that doesn't add value, and you don't want to do anything that adds or creates waste. Agile is just a way to try to do this, nothing else. You can do this in clean room, you can do this in any methodology if you do it correctly and right. You have different pros and cons, but the fundamental thing is the same. You want to add value. And if we look at that, the general problem is one size does not fit all, which means that the biggest sellers of Agile methodology, including, and also in requirements engineering, how you do requirements engineering in Agile, but also what tools you use, what methods you apply, that you use a backlog and how the backlogs look like, how you integrate this with Trello or whatever you're using. All of this is consultancy driven. Somebody wants you to do this because they can sell you stuff. The problem is they want to sell the same thing to many people to make money. The fundamental problem is that every organization, not even company, but part of a company, need a specific adapted way of working. One size that absolutely not fit all. You can't say Ericsson uses X, because Ericsson is 500 companies doing different things. And even in those 500 units, you have different parts. And doing the same way for all of them is a huge sub-optimization. And that's kind of the fundamental thing, because you don't start with value, waste, and overhead as philosophy and then figure out how you work. Rather, you start with, this is how we're going to work. And this is true for requirements engineering too. Not always you need to specify all requirements. Why? Because you've done them 100 times. It's a waste. Yeah, but some you do, yes. But then we need a method to actually differentiate what we need to specify properly and which we can skip to specify. And that's where an adaptive way of working comes in. And I think that's kind of important from the agile perspective, and that's why I think it's super important from requirements engineering, because everything that's in the method has implications on how we do requirements engineering. So value. This is the biggest problem. Every time I talk about value, I kind of redefine it slightly, because it's a slippery concept. If you look at it, value is ultimately what the product or service offers, right? So if you offer something that somebody wants to use, it's value in some sort of way. But that's a little simplistic, because what you want to do is you want to add value to your product or service. Doesn't matter if it's a plane or if it's a piece of software, it doesn't really matter at all. You want to add value. Value for a plane can be fuel economy, safety, security, and more luxurious seats. I mean, it doesn't really matter if it's software-based. It's still features and quality aspects. But you want to add things that people can draw benefits from. But here we have to be careful, because what if you have the most fuel-efficient plane in the universe? And the only reason I'm using planes as an example here is because I know we have some Embraer people with us. I'm sorry for that, guys. And I'm probably doing stupid examples. But think about this. You have an airplane that has very good fuel economy, very safe and secure, very luxurious. People love flying on it. And the pilots love driving it, okay? Flying it. But it's hugely complex to maintain. So do we have value then? Well, we have value for one or two groups, right? The passengers are happy, and the oil companies aren't, but the company is happy because they have less fuel consumption, and the pilots are happy, right? And the stewardesses, et cetera, et cetera. But the people absolutely not happy is the maintenance crew. And their cost goes up because it's complex. So all of a sudden you have some value for some, but value for not. That means that even in this simple example, you see that value is different things for different people, which means value is not one thing. And that's very important to remember. Another thing is you want to remove waste. And I'll come to waste later, but the waste is basically anything that is not creating value for anyone. But then you want to differentiate waste from overhead. And that's kind of complex. So let's start over. Waste is anything that does not add value. I think we can agree on that, and that's basically from lean. But overhead is everything needed to create value without adding value directly. And here's where the complexity comes in. And that is, let's assume I write requirements. Is that valuable? Well, probably not. In itself, writing a requirement doesn't add value. It's an instrument to achieving value, which means it's per definition overhead. But if you write a requirement that is not implemented and nobody reads, it's not overhead anymore, it's waste. And that's the tricky bit, because in order for you to work in a smart way in lean and agile, you need to be able to, before you know what it is, guess what it is. And that's the fundamental problem with value, waste, and overhead in lean product development overall, is that if you don't do repetitive tasks, like a production line, do the same thing all the time, again and again and again, but you do new stuff in new problems and new challenges, often like in engineering of software-intensive systems, it's very hard to preemptively figure out what's waste and what's overhead. So what you tend to do is you throw out stuff you think is waste, but it turns out to be overhead. Like, let's not specify requirements anymore, we don't need them. No, you don't need them, but 5 other groups in the company needs them. And after the product is released, we have to reconstruct the requirements to figure out what we tested. So you save money in one part, but then you lost a lot of money doing extra work afterwards because you skipped something. And this is sub-optimization. And that's what happens when you actually throw out overhead and think it's waste. So why is this important? Well, actually, there is there's something, we developed something a while back called software value map. And I'm not saying the software value map is a solution. What I'm saying is we try to figure out all types of value and put them in one place. And this is open source. You can basically go and log in there and look at the value aspects that are listed. And it's a work in progress. But the idea between the software value map is if you look at value, waste, and overhead, you can never ever figure out what waste is or overhead is if you don't know first how you define value. And that's what we kind of try to do, is define all types of value relevant for a product development instance for software intensive products. And basically you have 4 different categories of value. One is value for customer, which is the obvious one, right? But there are many types of value for customer which are more or less dependent on how important they are, is dependent on your domain, your context, your products. So for example, the ability to use multiple pieces of software in one infrastructure might be very important for me. While for another user in another product, it might be the usability of the product, or both. So there are about 100 different types of value aspects that can be important. And I'm not saying you need to learn all of them and use all of them because it's too many. What I'm saying is, if we don't define what it is, we cannot really use it. So when people say, I do value-based software engineering or value-based development, I ask them, what is value? And they say, oh, customer value. Yeah, but which customer value? And then generally, ease of use. Okay, well, that's 1 out of 40. Which are the other 39? And that's kind of the danger, that you need to be kind of specific as an engineer to figure out, what am I trying to achieve? Is the most important thing usability, or is something else? And I'm not saying it's easy to achieve it. I'm saying you at least need to know what you're talking about when you're speaking about value. And the most important thing is not that. The most important thing is everybody in a team, when they say the word value, they need to understand what everybody else means, which means you need to be fairly specific. But the interesting thing is, here is VP3, value perspective 3, which is internal business value. And internal business value is generally everything you actually need to do in a product to be profitable, to be able to develop it. So by doing a huge amount of custom adaptations, for example, you end up in a situation where the customers are very happy, but the cost for you to maintain the product is huge. And this is a classical example where you maximize the customer values, but you do not maximize the internal values. And the reason, and generally what you do is you see value as revenue, value for customer as revenue, and you see internal business value, you see that as cost. But this is dangerous because you always want to maximize value and you want to minimize costs. So what you do for internal costs, you try to put them down, right? Minimize them. And what you end up doing is throwing out the overhead, which is needed to create the value. And this you don't realize in 3 minutes. You realize this 2 years later, 3 years later. I'm not going to say anything because it's a little sensitive, but I'm going to give you a tip. Look at Microsoft Windows 10 3 years ago and today, and go and Google what has changed in the organization. And you'll find a real, live, interesting example of parts of this. And this is super, super complex, which means that it's not like any company is stupid and does this deliberately. Rather, it's very hard to do this because very few people have an overall view. A requirements engineer working in a specific project or a specific part generally doesn't have the big picture need. So if you look at value as an example, right? If you have internal values, which is basically the ability to use the architecture or the product or the infrastructure to maintain or deliver value, and you have external values, which is, for example, customer value, value actually can be seen as an index at a certain time. Doesn't matter if it's good or bad. I mean, it has value. Both internally, it can be maintained, and externally, customers use it. Then when a feature comes in to be implemented in the next iteration, it actually impacts that index and changes it. So in this example, feature 1, well, it increased the external value, but it made the architectural complexity slightly more complex, which means the internal value decreased. And this goes on and on. And you can do it the other way. You can actually remove some features and clean up the architecture, which means you do refactoring. And all of this is to say that value is not one thing, and it can impact a product both positively and negatively at the same time. And this is the interesting thing about value. And when you look at value, one decision, every decision you make in a product development organization, which is generally driven by requirements engineering, impacts value of the product or the component continuously in multiple ways. And it can be both positive and negative. So what I generally tell my customers or my partners is this: skip prioritization in your requirements. Don't have priority. Have internal and external value, and have a scale -3 to +3. This gives a much better indication for what impact a requirement has on the product. And thus, you can actually use a current concept priority, but introduce value instead of having a priority, which is, good or bad, or important, less important, which says you very little. But if a value is increased or decreased, it says more. And the interesting thing about value is a Rosetta Stone, right? You can use value for triage and selection. You can use value for impact on the current product. You can use value to figure out how to continuously improve how you work by measuring how much value you produce. And you can also use value as a communication instance. So basically, if you tell people why something increases in value, they can also understand why a feature is important, and also if they can improve the features. If an agile team gets a hold of a feature that has a positive value and they don't understand why, they will ask the right questions. And then they might actually either skip the feature or change the feature to be better. But the challenges, of course, with all of this is it's very hard to define value. It's extremely difficult to measure value. You can do it, but it's very hard to compare different types of value to each other. For example, how do you compare usability and maintainability? What scale are you using? We'll generally use dollars, but dollars is dangerous because it's a huge guesstimate. And if you guesstimate, you think it's accurate if you have $500, but it's actually not. So I actually suggest using a non-value chain like plus or minus 5, because it doesn't lure you into thinking of exactness of estimation. And I know I'm late, sorry guys. One last thing though is I would also say that how we work, all of these things I think are very interesting for future research and very needed. But I also think that how we work is important. And instead of doing too much of this, some of this we have to do because we have to publish. That's the game. But what we can also try to do is try to actually find challenges at company partner sites and actually separate them from symptoms, which is one of the most important things, because just because somebody says I have a problem with quality doesn't mean the problem is quality. That might be a symptom of the actual problem. But then actually develop candidate solutions that are then tried out, and you cycle this and you try to do it as fast as possible. And the good thing about working like this is you have no choice but to try out the solutions you're doing in reality, because otherwise you cannot traverse the cycle. And there's an interesting IEEE software paper about this if you're interested. But the idea is a macro model for how to work with industry. And of course you do publications here too. What I'm saying is here you kind of embed industry into the research, just as you do customer and on-site customer in an agile team if you can. I have some slides with tips and stuff, but I'll just move on to Q&A. Thank you very much for your attention.
Thank you, Tony. Great talk. Really thought-provoking.
Well, yeah, you don't. As a keynote, you don't have to be correct. You only have to be interesting.
Okay, very interesting. Very interesting. So now we are going to open to the audience questions and comments. So if you want to ask, just sign up in the chat box. So Juliette, you are the first.
Well, again, Tony, thank you very much. Very, very good talk.
Oh, thank you. Super.
Very important for the audience and for young researchers that are beginning to look into RE. And as by the end, you center on the centerpiece of your talk, which is value, which is it's very interesting that you kind of advise, don't prioritize, but look for value. And the thing of looking for value, it's an abstraction in the sense of requirements engineering, because you are several levels up, right? When you think of value, you're going to see that only when you see the work that links RE with product management, this is clear enough. Or when you talk about lean process and the aspect of value appears. The very interesting question of how do you confuse between waste and overhead, right? So the question of really defining what is a overhead, what is a waste, is of course is not trivial, right? And also it's very interesting, and I agree 100% on your vision of agile. That of course, as you shorten the feedback cycle, you get more information. So you are more rich in information, so better for the requirements in the sense of completeness. No question about that. But what happened is that usually you go from an organizational point of view that was hierarchically designed to an organization that now network organized.
Yeah.
So when you go to a network, it's very, very hard to control. So your point of loss of control in the use of agility, it's right to the point. Very, very, very nice. Thank you very much. And the other point is that I should be asking questions, but before I formalize my question, I have to set up the ground. Okay. Yeah. And you one thing about agile is that you said, look, a middle manager goes to a course, to a meeting, hears about agile, reads a book very quickly, and say, well, that's the solution, right?
Yep.
So I believe that this is one opportunity for academia, right?
I agree.
Is why didn't they talk to you before?
Well,
so,
many times companies come to me after they've decided to transfer, transition, and after they've had 5 or 6 consultants around for a year or two, and they still haven't solved all the problems they thought they would. And I come in and tell them the truth, which is you've generally traded one set of problems for another set of problems, because the complexity of your product development hasn't changed. And there's no magic bullet here. But one thing I think you can do with value is this. You can figure out what is value and decide that you agree on what it is and define it together. Doesn't matter how you use it, but if you have the same definition of it, you at least draw in the right direction, right? And the second you can do is you can actually use metrics to figure out if you're actually generating value. And that's, I think, is the solution in agile environments. You go from control, where you follow a process, to continuous measurement of efficiency and effectiveness based on metrics, which means you can do micro changes all the time. And I think that's kind of the trade-off you have to do when if you work in an agile environment. And the ability to measure value is very important. Sorry for interrupting. Please.
No, thanks. But yeah, I agree. But one point here, which was my question, just one question, is how do you, let's say in a more practical way, how do you really differentiate between the external value, which usually is the one that usually companies see more,
Yep.
to the internal value?
Yep.
And now, not just in terms of the whole company, but in terms of software engineering.
Yep.
I'm not saying it right. Not only in terms of software engineering, but about the product, because usually most of the products have the embedded software. So it's not just the case of the software, but the fact that the product will have a value for external value will impact in a new feature on the product. How this how you measure this internal value of this or internal overhead or internal waste of this feature?
Yeah, that's a good question. So you do it in the exact same way as you do it today, but you do it more explicitly. So today, for example, what you generally do is you enter a meeting, you decide what the next iteration should be, right? Which features you should include and stuff, and you use some sort of priority for this. And generally, priority is backed by some sort of estimate on business case, right? You kind of estimate how much revenue you will get or if the customer wants stuff. So what you do is, instead of doing that and talking about money, you replace it with value. And you look at the feature, let's say a backlog item or a feature, and you look at that and say, okay, if we implement this feature in this product, which value aspect will it influence the most? What's the purpose of this feature? Well, the purpose of the feature, say, is security, okay, right? Okay, security. If we implement it as it is stated here, will it increase security? Yes, it will. Okay, how much? Well, we estimate. Plus minus 3. Plus 2. Fine. Exactness is not important here. But if we implement this feature, what do we need? Well, we need a new encryption software. Do we own that? No, we don't. Okay, we have to, it's a black box piece of software. Yes, then we talk to the architect and say, how harder will the product be harder to maintain when we implement this feature in this way? And they say, ooh, it might be very secure for the customer, but from a maintenance perspective, this will kill us. Then all of a sudden, you have two simple value aspects, right? One is maintainability, which is an internal one, and you have customer security. Security is a feature, right? Which is an external one, non-functional aspect. So you have a positive one and a negative one in the same discussion. So then you can choose, let's do it anyway, or you can say, how can we change the requirement so that we don't have this negative part of maintenance? And you actually talk to the engineers and the architects and not to the managers on this. And they say, well, we can use an open source standard. Yeah, but that's not as secure. Then this goes down a little. Yeah, but this goes up a lot. So from going from +3 to -3 in two perspectives, you might go from 0 to +2. And that's practically how you do it in an actual decision meeting for sprints. And the good thing is, instead of saying, oh, we sell this, we implement this feature, we get 5 million. How do you know that? It's guesswork, but we get 5 million. Oh, that's very important. And then an engineer raises their hands and says, yeah, but it's going to be hard to, shut up, we get 5 million. You avoid that discussion. You have a discussion about plus and -3 and two different value aspects, one internal, one external, as a simple example. And you have the discussion on the same level of power. And that's the really good thing about discussing value instead of revenue, instead of business cases, instead of priority, right? Oh, high priority, low priority. Doesn't say much. But customer usability or customer security, external value, maintainability, internal value, it's much more information-rich priority way. So this is practically how you do it. Now, is this exact? How do you know it's +3 and not +2? You don't. Absolutely not. It's pure guesswork. But it's exactly the same level of accuracy as you do today with business cases. There's no difference. So I'm not saying this fixes everything. I'm just saying it's a new way of discussing things. And that gives the necessity to discuss it with a better and wider audience. And it takes internal aspects into account earlier in the product development. And what that has shown, when we've implemented value-based product development in this way, it's shown that technical depth is radically decreased over time. And the simple way, and the simple explanation is, you get the architects and the developers into the product development discussion earlier on the same level. And not, oh, these are the 50 features we're doing, business case is 50 million, we'll make a lot of money. Architects raise their hands saying, yes, but this, yeah, we'll solve that later. And that's, this, we'll solve that later. That's literally how you implement technical depth in a product or organization. So that's kind of the perspective of value from a product perspective. Now, if you look from value from an organizational perspective, the same principle applies. If I do a change in my organization, say I divide my teams in smaller teams, right? Do we produce more valuable features? Do we produce more story points? You can measure whatever you want. Do we have fewer defects? All of these metrics are value driven in terms of that you figure out that the more defects you have, the less features you can implement. The more features you implement, the better. And was the feature successful? Did the customer like them? Yes. Well, that's an indication of selection quality. So all of these can be measured in some indirect way. It's not perfect. And then the agile teams, but also the product management teams and the decision teams and the senior management teams can actually measure their performance and say, oh, we divided ourselves into smaller teams and the metrics don't look good. Maybe we should go back to larger teams. Today, what you do is you follow a recipe. You basically say, okay, we had a consultant, he teaches us how to do SAFe, and he said we should be 15 people teams. Why 15? Why not 12? Why not 61? There's no knowledge behind this. This is people making their living convincing people. That's where I think you're completely right in relation to our role. When we go out as scientists and work with industry, we're not dependent on hourly rates. We're not dependent on selling a product. We're dependent on solving real problems and having evidence that we solve them. And that's the golden thing about being a researcher, especially for younger researchers. Yeah. Sorry, long answer, I'm sorry. But it's a big topic.
Okay, thank you.
Well, thank you.
Thank you.
Thank you. Let's move on. So, Jaelso, it's your turn.
Okay, Tony, it's always good to hear your insights. Always really surprised by your remark that you don't have time or interest, or it's not valuable to write the papers that you could have written. So many experience that you have in this setting up this collaboration between academia and industry. So what can you suggest to overcome this barrier? Because you are well known for technology transfer experience, but now we hear that you don't have time or you don't have interest to share your findings, and that is it's really quite problematic from the academic point of view. If guys like you that have all these good experience in doing this collaboration don't share or don't if you are not able to have some time for sharing this experience, so what can we do about it?
That's a very, very good insight and question. So first of all, I absolutely have interest, and I absolutely understand the importance of sharing and publishing. But I see two things I'm sharing. One is the actual transfer of solutions, if you will. Sometimes if I manage, when I say I mean my team and my colleagues, not only me, but many times we put a lot of focus on transferring knowledge and ways of working and solutions to industry and trying them out. And then we get new problems, right? We solve some, but we get new, and then there's a lot of pressure from industry for us to start working on a new problem as soon as possible. And this is super interesting because we get money, we get interest, we get collaboration, we get access, So it's very dangerous because you kind of say, I'll publish that later. And then continue, and then again, same thing, publish that later. And all of a sudden you have 10 things in your queue you should have published. And it's really sad. And I don't know how to solve it, to be completely honest. I'm trying. I'm working a lot, and I'm trying to solve that as much as possible. I think that it's unfair if you have a PhD student and you kind of give them this and they should publish, right? Okay, it can be good for them. They finish faster, but they don't do their own research. So that's not a good idea. Well, I could work less with industry and publish more, yes, but then I kind of lose the industry part. So I think it's a balance we have to find. And I think that, to be completely honest, I think I am at the stage where I've gone too far towards working with industry and publishing too little. And probably in a year or two, it will have changed a little like this, right? So it kind of goes like this all the time, right? Too much work with industry, too little publications, too much focus on the academic part and publication, and too little work with industry, right? It kind of goes like this. I would say the senior researcher, when you're responsible for many younger ones, it's even worse, because then you kind of not only have to work your stuff with industry, you have to help them get started with their stuff with industry. So it's a very difficult problem. And I'm not saying you shouldn't publish. There are two reasons for publishing. The trivial one, which is your career and stuff like that. The more important one is sharing the knowledge and the mistakes and the good things and the bad things with your fellow researchers, so that more brains can work on the problem and solve the problems. This is the point of publishing, and this is super important. It's just that it's so hard to kind of find the balance. I'm sorry I didn't have a good answer for you, but you're absolutely right that this is critical to have both.
Okay, so thank you.
Thank you.
We are a little late, but Sabrina, are you hearing us? You can put your question, and this will be the last one.
Hi, Jack. Thank you, Luis. Hi, Tony. How are you?
Hi, I'm good. You?
Thank you. I'm good. I'm good. Thank you for the great talk. I was wondering, as you were giving a talk, I was wondering about teaching. If you think, right, it's a big challenge nowadays, much more than 10 years ago, to teach requirements engineering to undergrads, right?
Yep.
So I like very much in working with you guys in Europe, because I'm very much in love with the Capstones project idea, right? You can put a lot of disciplines within one course and you can practice at the same time, but this is still a challenge in Brazil. Most of our undergrad curricula still works with having one course for each one of the disciplines in requirements engineering. So could you share your thoughts on ideas on what you think that we are heading to on teaching?
Yeah, I think that's a very good observation, and I think teaching, like everything else, has to evolve. So I actually think I'm a little old-fashioned in some cases. So for certain subjects and at certain levels, I think, and this is backed by science, traditional teaching is better. You know, you're literally standing in front of 80 people, 100 people, and you're giving them knowledge. And for certain things, that's good. But they cannot really, and that's more data transfer. If you're going to actually transfer knowledge and have them apply it, you need to combine it with practical tasks. And in reality, when you work in software-intensive product development, you don't work with requirements engineering, you work with product development. And requirements is very important, but it's a part of this. So what we try to do, and we're always trying to do this better and better, so I'm not saying we're finished or succeeded, I'm just saying the way we're moving is we're having more of a lab environment where students can actually choose a piece of technology or a piece of or a problem they can work on in a project, more of a project setting. And within that project, you should deliver a complete working something. Now, within this project, you have 3 courses. You have requirements engineering, you have design of some sort, and different types of design, and you have realization, testing, etc. Right? Which means we kind of try to mimic a small development project for a product and include the competence from 3 or 4 courses in the same time. We generally do this for 6 months and in groups of 4 to 6 students, and they can kind of divide the roles, and they get project management and agile methodology and requirements engineering and design and architecture and component based. They get all of this. They have to apply all of this, but in a real scenario where they actually have a customer, and sometimes it's a real company that wants something, a prototype or something. Sometimes it's a teacher acting as a customer, right? And that's kind of a nice way to package it. And yes, it's a new way of thinking to some extent, but the cost is not much larger. It's actually less, because they write reports, daily journals, each student, and they write the report and they supply a product in the end, which means you don't have to have exams or stuff like that. And this kind of works very well because we try to mimic a real development instance with different needs. But before they do this, they have some basic introduction, right? What is a requirement, for example, or how do you design stuff? But we don't go too much into that. Rather, we give them basics, and then they can explore that themselves. So they can choose if they want to work with a backlog in a certain way, or if they want to use UML or not, or if they want to use C# or Java. We don't care, right? They're engineers in the company. And I think that's a nice way to try to start solving the challenges. I'm not saying we're there yet. I'm just saying that's one way. And in some cases, we've also included industry in this. So we have a couple of engineers from a real company working in the teams. And that works very well, because then you kind of get real sharing of experience and knowledge for the students.
Yeah. I agree with that. And we have been trying that. That has been working quite well for grad students, but for undergrads, it's still a challenge, right? Just because the way that that we have the curricula imposed by us. Right. Yeah, we have to change our minds to be able to do that, right?
I think you can do small changes. We start the first year with an individual small project where we do it much scaled down. The second year of engineering students, they have a larger team project of 4 or 5 people, and the third or fourth year, they have a 20 people large project.
Oh, I see.
And these are big stuff, right? So real problem. But it has its own challenges, of course, right? What if they don't succeed?
Yeah. Okay. So enough for us to think about. Thank you.
Okay, guys, thank you very much. We had a very interesting discussion here. Unfortunately, we don't have more time. So again, I would like to thank you, Tony, for accepting our invitation to participate in WER this year. It was really great talk, very insightful and thought-provoking. Thank you.
Thank you, guys, for having me, and stay safe and stay well, and talk to you soon.
Yes. I hope we can meet very soon in person.
Yes.
Yes. So now we are going to move into the next technical session, number 5. So Johnny, are you hearing me?
Yes.
So you can assume it now, please. Thank you.
Okay.
Thank you, guys.